I hope all of you are doing good. Let's start today's chapter, set theory. In day-to-day life, we need to deal with collections of persons, things, numbers or items. Consider the following examples. Number 1, a collection of plays of Shakespeare. Number 2, a collection of books written by Rabindranath Tagore. Number 3, a collection of paintings. Number 4, a group of students of class 6. Number 5, all the letters of the English alphabet. Number 6, all days in a week. So each of the above collection is a set, means all these are a collection. All these collections are a set. Okay. So in this chapter we shall learn the meaning of a set, representation of a set, the different types of sets and the cardinal property of a set. Okay. Set. A set is a well-defined collection of objects. The objects that belong to a set are called the members or elements of the set. Well-defined collection of object means that given a set and an object, one should be able to say definitely if the given object belongs to the set or not. Consider the examples given below. Number 1, a group of good students is not a set because the objects are not well-defined. The word good is a relative term. Number 2, a group of class monitors is a set since all the objects of the set are well-defined. Number 3, a group of old players is not a set as the ages of players are not given, right? And number 4, a group of natural numbers up to 15 is a well-defined set. The objects are natural numbers up to 15. Okay. Next, representation of sets. Sets are represented by the following method: description method, tabular form or roster method, and rule method or set builder form. First, let's talk about description method. In this method, the description of elements of a set is enclosed in curly brackets. Examples: the set of natural numbers less than 15 is written as natural numbers less than 15 in curly brackets. We always write description method in curly brackets, right? Number 2, the collection of all days of April is written as all days of the month April, right? Number 2 is tabular form, or you can say roster method. In this method, all the elements of a set are enclosed in curly brackets and the objects are separated from each other by commas. Example: the set A of natural numbers less than 8 is written as, okay, less than 8 always written in curly brackets, 1, 2, 3, 4, 5, 6 and 7. These are the natural numbers which are less than 8. Okay. Second, the set B of vowels of English alphabet is written as C. B, set of B, and in curly brackets you will write vowels of English alphabet, that is A, E, I, O and U. And 3, the set C of all letters in the word Delhi is written as C is equals to, then in curly bracket, D, comma, E, comma, L, comma, H, comma, I. Points to remember. Number 1, the roster form enables us to see all the elements of a set at a glance. Second, a set may consist of a single element. For example, if set A has only one element, X, we write A is equals to X, then in curly bracket. Okay. 3, the order of listing in a set can be changed. Thus, A is equals to 5, 6, 7. Okay, A is equals to, then in curly bracket, 5, 6, 7. And this can also be written as like 6, 7 and 5. You can change the order, right? 4, if elements in a set are repeated, that the set remains the same. Thus, the set 8, 9, 8, 9, then 10, 10 is same as 8, 9, 10. Okay. And 5, each element of the set is listed once and only once. Okay. Thus, the set of A letters in the word India is written as, okay. So, there are 2 I in India. So, we will write I, N, D and A. Okay. 6, when the number of elements in a set is large, we can represent the set by writing a few elements that clearly indicate the structure of the elements followed by 3 dots and then writing the last element if it exists. Thus, set A of natural numbers below 100 is written as 1, 2, 3 and so on up to 99, right? Some standard sets of numbers in tabular form. Number 1, the set n of natural numbers is written as n is equals to in curly bracket 1, 2, 3 and so on, because there are so many natural numbers, you cannot write all of them. Okay. Number 2, the set w of whole numbers is written as w, then in curly bracket 0, whole number starts from 0, 0, 1, 2 and so on. 3, the set I of integers written as I, then in curly brackets -3, -2, -1, 0, 1, 2 and so on. And 4, the set E of even numbers is written as E is equals to in curly brackets -4, -2, 0, 2. Okay. C, rule method or set builder form. In this method, we write a variable say x representing any member of the set followed by a property satisfied by each member of the set and enclose it in curly brackets. Thus, if A is a set consisting of elements x having property y, we write, see, how do we write? A is equals to, okay, let me show you how you're going to write it. A is equals to, then in curly brackets x, then these two dots, x has the property y, and then curly bracket closes. Okay, now this symbol, what is the symbol? This symbol stands for such that. Okay, and the bracket is read as, how you gonna read is as the set of elements x such that x has property y. Okay, so this dot means such that. Okay, so examples, the set of natural numbers less than 20 is written as A is equals to x such that x, okay, now there is another sign n, then x is less than 20. Now it is read as the set of elements x such that, okay, x belongs to n. Okay, this means belongs to n and x is less than 20. Number 2 is the set B of all letters in English alphabet in the set builder form is written as B is equals to x such that x is a letter of the English alphabet. English alphabet, right? And 3, the set C of days of week is written as C is equals to x such that x is a day of the week, right? Now types of sets. Finite set. A set that has limited or countable number of elements is called a finite set. For example, A is equals to x, y, z is a finite set having only 3 elements, right? Number 2, B, x such that x is the teacher of my school is a finite set because there are finite number of teachers in your school. And C is equals to x such that x is a day in the month of June is a finite set having 30 elements, right? Infinite set. A set is said to be infinite if it has unlimited or uncountable number of elements. For example, the set of whole numbers, this is infinite because you cannot, because there are not finite whole numbers. Okay, so we will write it like this. The set of positive even numbers, even positive even numbers are not finite. Okay, and number 3, S is equals to x such that x is a star, and each one of above is an infinite set, right? Next, empty set or a null set. A set that contains no elements is called an empty set. It is also called a null set. A null set is denoted by this, which is known as phi. Okay, or we can also use curly brackets. This symbol is read as phi. It is a Greek letter. Okay. For example, A such that x belongs to n and 2x is equals to 0. B is equals to x such that x is a month of a year having 32 days. 3. C is equals to x such that x is a triangle having 4 sides. Okay. Equal sets. 2 sets are said to be equal if the elements of both the sets are same or identical. For example, let A is equals to 5, 6, 7 and B is equals to natural numbers between 4 and 8. And natural numbers between 4 and 8 are what? 5, 6 and 7. So, set A and set B, or simply you can say A is equals to B. Okay, these are equal sets. Now, equivalent sets. 2 sets are said to be equivalent sets if the number of elements in both the sets are equal. The elements may be the same or different. For example, consider A is equals to A is equals to, then in curly brackets, A, B and C. And B is equals to Delhi, Goa and Chandigarh. Right. Here A and B are equivalent sets because both the sets have equal numbers, means 3 elements. 1, 2, 3, 1, 2, 3. Okay, these are not equal sets but equivalent sets as they have equal number of elements. Right. Points to remember. Equal sets are always equivalent. 2. Two empty sets are always equal. 3. Two infinite sets are always equivalent. Next is disjoint sets. If two given sets have no common elements, the sets are called disjoint sets. For example, the set A is equals to 1, 2 and 3 and B is equals to 5, 6, 7. These are disjoint sets. Second part, the set C is equals to students of class 6 and D is equals to students of class 10 are disjoint sets. Okay, because they do not have any common elements. That's why they are disjoint sets. Overlapping sets. Two sets are called overlapping or joint sets if they have at least one element in common. For example, the set A is equals to 1, 2, 3 and 4 and the set B is equals to 4, 5, 6 and 7. These are overlapping sets because 4, the element 4 is common in both. Okay. Number 2, let's set A is equals to students of class 6 of my school and set B students of class 6A of my school. So these are overlapping sets since students of class A are common to both A and B. Okay. Now, cardinal numbers of a set. The set of distinct elements in a finite set is called its cardinal number. The cardinal number of a finite set A is written as n and then A. Okay. For example, A is equals to x, y, z has 3 elements. So, how we will write it as? In bracket A is equals to 3. Set B is equals to Delhi, Kolkata, Mumbai and Chennai. How many elements are there? 1, 2, 3 and 4. So, we will write 4. Okay. Example 1. Now, we have to state which of the given collections are sets. Group of even numbers less than 20. It is a set as elements are well defined. Number 2, collection of good books in the school library. Okay, good books. This term is a relative term, so it is not a set. Number 3, group of good colleges in India. Again, good colleges. What is good colleges? It is a relative term, so it is not a set. Number 4, group of vowels of the English alphabet. Of course, it's a set. Okay. And 5, collection of months of a year having 30 days. Of course, it is a set. Okay. Let's do exercise 5.1. Take the collection which are sets. Okay, collection of wise men of India. Is it a set? No, it's not a set because wise men is a relative term, wise. Okay, so it is not a set. Collection of member states of India. Of course, this is a collection. This is a set. Collection of young people of the world. Young people of the world. Young people, this term is a relative term. Okay, so it is not a set. Collection of students of class 6 in your school. This is a set. Collection of people above 60 years of age. Of course, this is also a set. Right, student? Operations on sets and Venn diagrams. In this chapter, we shall discuss the following concepts. The union of sets, intersection of sets, Venn diagrams, use of Venn diagrams to show relationship between sets. Union of sets. The union of two sets A and B is the set that has all elements which belong to either A or B or both. Okay, so it is written as A union B. Okay, this is A union B. So, for example, A is equals to small a, b, c and B is equals to small a, e, I, o, u. Then, okay, have a look. A is equals to A, B, C and B is equals to, all the vowels are there, A, E, I, O, U. Now, A union B is what? A union B is A, B, C. Okay, we will not write this A again. E, I, O and U. Right. Similarly, if C is equals to 1, 2, 3 and D is equals to 3, 4, 5, we will write all the numbers. Okay. 3 is repeating here, so we will write 3 only once. And third is, if n is equals to set of natural numbers and I is the set of integers, then n union I is equals to I. Okay. Now, intersection of sets. The intersection of two sets A and B is the set having all elements belonging to both, okay, both B and A. And how it is written? Okay, let's have a look. We write it as, okay, this means A intersection B. For example, A is given here 1, 2, 3 and 4, and B is what? 1, 3, 5 and 6. Now, A intersection B is what? Which is in both, which elements is in both these sets? Okay, we will write that element only. So here, as you can see, 1, so you will write 1 and 3. Okay, so we will write only 1 and 3 because only these two elements are same in both these sets. Okay, and number 2, if C is equals to A, B, C, D and D is equals to A, E, I, O, U. So C intersection D is what? C intersection D is only A, right? Next, Venn diagrams. John Venn was the first mathematician to use geometric figures to represent sets and the various relationships between them. Hence, such diagrams are called Venn diagrams. Normally, closed figures like a rectangle, square, circle or oval, etc. are used to represent a set. The elements are either written or marked as point inside the closed figure. For example, the set of vowels of English alphabet V is equals to A, E, I, O, U may be shown as like this. Number 2, the set A of natural numbers less than 10. Less than 10 means we will write all the numbers from 1 to 9. And that can be shown like this. However, in such cases where the number of elements is very large, only the description of the element is given. For example, the set D of all students of India under 15 years can be written as like this, because we cannot write the number of all the students. So we will write description here, that is a student of India under 15 years. Okay. Use of Venn diagrams. Venn diagrams clearly explain the relationship between sets in the following cases. If two sets A and B are overlapping, then A union B and A intersection B may be shown like this. This is A union B, okay, and A intersection B is this shaded portion, okay. Third, if set A and B are disjoint, then A union B and A intersection B may be shown like this. They are disjoint, okay. And also, A union B and A intersection B is equals to 5. Third, if the set B is fully contained in the set A, then A intersection B and A union B and A intersection B may be. See, what is written? If set B is fully contained in the set A, this is set A and set B is fully contained in it, okay, right. So this is A union B, and what about A intersection B? See, this is A and B is fully contained in A. This is A, this is B, okay. So this is A intersection B, right. Let's do example 1. Let A is equals to 1, 2, 3 and 4 and B is equals to 6, 7, 8. We have to find A intersection B and A union B, okay. So let's have a look. A is equals to 1, 2, 3, 4 and B is equals to 6, 7, 8. So first we have to find A intersection B. Okay, so what will you write here? 1, 2, 3, 4, 6, 7, 8, right? Okay, and now A intersection B. What will be A intersection B? Nothing is common between these two sets. So what you're going to write is A intersection B is 5. Okay. Now if we have to represent them by Venn diagram, see, this is the Venn diagram for A union B. This is A, this is B. Okay. Nothing is common between these two sets, and this is A intersection B, that is equals to 5. Okay. Exercise 5.2. Represent the following set by Venn diagrams. A is equals to x such that x is a natural number less than 8. Okay, less than 8. 1, 2, 3, 4, 5, 6, 7. Okay. All vowels of English alphabet. Okay, this is A. Okay. B and English alphabet A, E, I, O, U. Okay, students, now you will do practice of the remaining questions. Okay. Learning outcomes. A set is a well-defined collection of objects. 2. Sets are often denoted by capital letters and their elements are denoted by small letters. Okay, remember that. A set is written by description method in roster or tabular form and in rule method or set builder form. 4. A finite set is limited or countable number of distinct elements. 5. An infinite set has unlimited or uncountable number of elements. 6. A set that has no elements is called a null set and is written as phi or curly bracket. 7. Two sets are called disjoint if they have no elements in common. 8. The two sets are called overlapping or joint sets if they have at least one element in common. 9. The union of two sets A and B written as A union B is the set of all elements that belong to either A or B or both. 10. The intersection of two sets A and B written as A intersection B is the set consisting of the elements which belong to both A and B. 11. For any set A union A is equals to A and A intersection A is equals to A. And A union phi is equals to A but A intersection phi is equals to phi. Number 12. In Venn diagram, set are represented by closed figures like rectangle, square, circle or oval, etc. Elements of the set are shown as points inside the figure. Okay. So students, I hope you have understood this chapter. This was very interesting chapter and now you will do practice of this chapter.